Math 3 students. Today we are going to go over how to graph the square root function. Okay. So as with any graph, what we'll do is we'll put it on Desmos just to kind of get an idea of what it looks like. If ever you're given a problem where you need to graph something and you're like, I have no idea how to graph that, one thing I suggest you do is just make like an XY table, and that's going to, you put in some inputs, get some outputs, get some points to plot, okay? So that's just kind of a good general strategy when you have a function that you've never plotted before, you don't know how to plot. However, we have Desmos at our disposal here, so I'm going to go ahead and plot it for us. So I did the square root of x. Okay, and obviously we have our inputs, we take the square root of it, and then that's our output. Now the problem is we can't take the square root of a negative number, so if you try to put in a negative number, you get undefined. So this function has what we call a restricted domain. Since you can't put negative numbers into it, you have a restricted domain. You can't plug in negative numbers. And to get the outputs, we take our input and take the square root of it, right? So like 0, square root of 0 is 0. Square root of 1 is 1. Square root of 2 is a decimal. That gives us a gross number. Square root of 3 is a decimal, gross number. Square root of 4 is 2. 5, 6, 7, 8 are all going to give us gross numbers, but then we get to 9, we get a 3 as an output because the square root of 9 is 3. So you can get outputs of positive numbers for anything, but you're only going to get nice outputs when you're taking the square root of a perfect square, okay? So we can go ahead and at least plot this, right? We can see that we start here at, pen work. Sorry, there we go. We can see that we start here at 0, 0, and then we got 1, 1, and then for 2, it was 2.41. So that's kind of gross. And I'm not super concerned about you guys graphing the gross ones. Like I'm plotting it for like continuity's sake. But the big ones I want to make sure you guys know how to plot are like the perfect squared ones. Okay. So let's see. Okay, so that's the end of the perfect square ones for this because 9 is off the chart, right? So we can go ahead and connect those. Why does it not want to go back to drawing? There we go. And this just continues on. That's what the shape of this this function looks like. It goes off in the one direction there. Doesn't go off at all towards the left because, like I said, it has a restricted domain. Okay. So here, for the parent function, the domain is going to be 0 to positive infinity. Because if we look, right, we can plug in 0 and then any number that's positive. We cannot plug in a number that's negative because we get an undefined value. And then for the range, right, if we look at our outputs that we're getting, right, all of these outputs that we're getting are positive, okay? And they do start at 0. So our range is going to be from 0 to infinity, okay? Now, we can do transformations on this parent function, and it's very similar to how we did transformations on quadratics last year, right? If you recall, just a quick memory here, with quadratics, we had like a x minus h squared plus k, and these numbers here would move around the vertex, right? So you would like switch the sign of your x, keep the sign of your y, and that would give you kind of like your new middle point, right? And that's going to be very similar to what we're going to do here. As you can see, kind of the starting point for the parent function is 0, 0. And as we move that starting point around, it's going to move the 0, 0 around. Okay, so we'll call that our endpoint. Okay. And then if you recall the a value out in front, that like stretches and compresses it. It's going to make it, grow really fast or grow really small. Or if it's negative, it can reflect it. Okay, so here, if I go slap a negative in front of this guy, you'll see. Oh, it's still plotting my points from this. But you'll see, right, it reflected it there. Okay, so let's go ahead and take a look here at the first example. First off, it's asking what our a value is. So if you look, the a value is the guy out in front here. So our a value is just 1. All right, so that means that we don't have a stretch, we don't have a compression, and we are not reflecting because it's just positive 1. Now, our endpoint, that's our starting point, right? So to find your endpoint, you switch the sign of this guy for your x, Keep the sign of this guy for your y. So our endpoint's going to be -1, -5. All right. So we're going to go -1 and then -1, 2, 3, 4, 5. Okay. Now, if you recall, right, our parent function, I'm going to draw this in black so you guys can kind of remember where we were at. I'm going to put the big points on there. So we had 4, 2. This is what our parent function looked like, right? So we moved the function to the left 1 and then down 5. And there was no stretch, no reflection, no compression. So all we need to do is shift this graph. So we can just take these points from the parent function and move them left 1, down 5. So left 1 and then down 5. 1, 2, 3, 4, 5. That would be this point, okay? He ends up right here. Then I go move this point. We're going to go left 1 and then down 5. 1, 2, 3, 4, 5. I end up right there. So my new function is going to look like this. All right. So now it's asking for the domain. Well, they gave us kind of these nifty things here where it shows what the domain is based on the transformations. So the domain is h to infinity. Okay. Well, our h here is -1. So our domain is going to be -1 to infinity, which makes sense, right? If you look at the x values that we're getting outputs for, they start here, right? And they go on to infinity. Good. All right. And then we have our range. So if we look, our range comes from, it's going to be k to positive infinity or k to negative infinity. So if there's no reflection, it's going up. So it's going to be k to positive infinity. So in this case, it's going to be -5 to positive infinity. Now I know they don't have it written here to like write out the transformations, but you guys need to know how to do that. So let's list out the transformations here. So this guy is going to go to the left 1 and then 5 down. All right. All right. Let's see. Let's try this next one here. Okay. So for this guy, we can see that our A value is actually -1. All right, we do have a transformation going on here. And then our endpoint, well, there's no number in there with the x on the inside of the function, so that's actually going to be 0. And then our k is going to be -2. All right, so when there's nothing on the inside there, it's 0, right? And then if there's nothing on the outside, it's 0. That's why, like, this guy here for the parent function, our endpoint is 0, 0, okay? I guess we didn't, like, blatantly write that out. Okay, so then for our domain, right? Well, I guess actually, sorry, we'll do that after we graph. I'm getting too excited here. Okay, so I'm going to go ahead and plot the parent function first, right? So we have 0, 0, we have 1, 1, and we have 4, 2. Okay, so we've got that. Now, what we should do at this point is I would like to go and deal with the reflection. Okay, so we know that we are going to reflect it over the x-axis. Okay, so all you do, this guy's like 1 away, he's going to go here, this guy's 2 away, he's going to go 2 down here. Okay, so you just have to essentially reflect those points across the axis. Now, we're not done. This is just me reflecting the parent function. And then we have to go and shift it as well. Okay, so this was dealt with by doing this reflection here. And then now, with this -2, right, we need to go ahead and move our starting point to -2. Okay, we didn't go left, right at all, right? So all we have to do now is these points that we just reflected, we just have to move them down 2. So we're going to go 1, 2, and 1, 2. Just like that. Now we can go ahead and take a look at our domain. If we look, our domain is going to be from 0 to infinity. Looking at the graph, so the graph is the red one, okay? If we look, the x values that we're getting, they start here at 0, they go to positive infinity. And then for our range now, this graph is going down to negative infinity, okay? Because it was reflected. So our range is going to be from our k value, which is -2, right? We can see the y values outputs that we're getting. They start here. And we're going to get y value outputs until -infinity. Now, if you're giving me the transformations, that's going to be a reflection. Oops. And we went 2 down. All right. Let's go ahead and we will try this one here. This one's a little bit tougher. All right, so we have our A value, which is 3. Now here, our endpoint is going to be, remember you switch the sign of the guy on the inside, so that's going to be 3. And there's nothing on the outside there, so that is going to be 0. So 3, 0. All right, so again, I'm going to go ahead and I'm going to draw the parent function, and we're just going to move it around accordingly. Okay, so you do have to have this parent function memorized. It's 0, 0, 1, 1, 4, 2. Okay, and if you ever get, like, if you ever forget it, just make a chart, right? Like, okay, if I have an input of 1, I get a 1 out, right? If I have an input of 4, I get a 2 out, and so on. All right, so now what this 3 on the outside is going to do is that's going to stretch it, okay? So what happens is our y values are going to essentially all be multiplied by 3, okay? So here, right, 0, you can't really multiply by 3, so he's going to stay there at 0, 0. And then our output here is 1. 1 times 3 is going to give us 3. And then here for 4, our output is 2, right? So we're going to multiply 2 by 3, and we get 6 as our output. Okay? So far what we've done is we have applied this transformation. So now we have to go ahead and apply the -3 transformation. All right? If you look, right, our new starting point is going to be at 3, 0. So we're going to take our endpoint here, and we're going to go 1, 2, 3. That's our new starting point there. And we didn't go up, down at all. We just went to the right 3. So we're just going to move all of these points respectively. So we're going to go this guy 1, 2, 3. So he goes right here. And then this guy 1, 2, 3. He goes right here. All right. So that is what our final graph should look like. Okay. I have no issue with you having like all these graphs there on like your assessment, and then you just like highlight the final one. I'm totally fine with that. You just have to like specify, like, obviously, like this is my final answer. So I guess, like, you know, here, if this is a test, I didn't read, but we should highlight it like, hey, that's my final answer, all right, and let's see. So for this one, our domain is going to be 3 to infinity. And then our range is our k value, which is 0, right? That's like the y value that we start at. And this one goes up, so that one's going to go to positive infinity. For our transformations, that is just going to be a stretch. And we went 3 to the right. All right, we're almost there. Let's get through one more. All right, so here, our a value, we've got -1/2. So I'm going to go ahead and draw our, I guess we should also add in our endpoint. Switch the sign of this guy, keep the sign of this guy. So we get -1 and 2. So I'm going to go put in our parent function, 0, 0, 1, 1, 4, 2. All right. And now let's go ahead and apply our transformations. First, I'll go ahead, I'm going to deal with the 1/2 situation. Okay. I would deal with your a value first and then deal with the shifting up, down, left, right thing after the fact. So let's deal with our 1/2. What's going to happen with that is, all of our y values get multiplied by 1/2, right? So obviously my 0, 0 is still going to be 0 there, because 0 times 0 is 0. And then my 1 times 1/2 is going to give me positive 1. And then, or sorry, positive 1/2. And then my 2 times 1/2 is going to give me a 1. So that deals with the 1/2 situation. And now we got to deal with the reflection. Now, if you want to do this at the same time, you're also welcome to do that. You know, if you, instead of like writing the red one, you could just go straight from the black one to the blue one. I'm totally fine with that if you know, like doing it that way in your head. But now all we got to do is like reflect this over the x-axis. This guy is like a half away, so he's just going to go a half down. And then this one is 1 away, so we're going to go 1 away in that direction. All right. So at this point, we've applied that transformation. So now let's go ahead and do our final, which is just going to be shifting everything up, down, left, right. So our new starting point is going to be -1, 2. Okay, so we went left 1. We moved this guy left 1 and up 2. Okay, and again, remember we're on the blue guy, right? We started with the black, went to red, now we're blue. So we moved this blue dot to here. And again, we're going left 1 and up 2. So I'm going to take this blue dot. I'm going to go left 1 and up 2. So left 1, up 1, 2. That's going to get me right there. Just going to erase that so it's not as messy. And then this blue dot here, we go left 1 and up 2. 1, 2. So we're right here. All right. So now we can go ahead and draw that in. And that is what our final answer would look like. We've applied all the transformations. So our domain here is going to be -1 to infinity. Our range is going to be 2 to -infinity, because this is one of those reflection ones. This guy's got a lot of transformations. The transformations here are going to be a reflection, and then a compression. If this guy makes the y value smaller, right? We went from like 1 to 1/2, 2 to 1. That's a compression. Here it made the y values bigger. We went from 1 to 3, 2 to 6, right? That's a stretch. So we had the reflection from the negative, the compression from the 1/2, and then the up, down, left, right, we went right 1. No, we didn't. We went left 1. We went left 1. And then we went up 2. So that would be all of our transformations.